Good morning. I wanted to go over the relationship between an arc, a sector, and the rest of a circle. I know this is something we've been kind of struggling with in class. So I apologize for the shaky video. I'm filming myself right now. If you take a look, we've got our circle B over here. And we can see that it is labeled with some information, and we are told some information. So the first thing that we need to do to figure out everything we can know about the circle is to really identify what we already know. So when I write this 12 inches over here, first of all, you might be wondering, is that an area or is that a length? Well, the key to this is looking at our units. 12 inches is a length. I know it's not an area because area has square units. Because it's written right next to arc AC, it's safe to make the assumption that that is the arc length. So the length of arc AC is 12 inches. The other thing I'm observing is that number is not in pi notation. So I know that pi has been multiplied through. I'm not worried about pi notation. I'm told up here that the measure of angle ABC is 70 degrees. And so that's going to tell me that the central angle of this arc is 70 degrees. So another way we could write this is we could say the measure of arc AC is 70 degrees. Now keep in mind, when we use that little m, we're talking about an angle. If I'm talking about the arc length, I will specify by using the word length. All right, so those are the things we already know. Actually, there's one more thing we know, and we know that all circles have a central angle of 360 degrees. So all circles have a central angle of 360 degrees. Okay, so let's think about what we can find from this. What can we learn about the circle from these three pieces of information? Well, the first thing that should come pretty natural to us from the proportion that we've been working with is the circumference. If I know the arc length and the central angle of the arc, the easiest thing I can find is my circumference. So let's do that. So we're going to find, and the first thing we're going to find is the circumference. And we might want to keep in mind that circumference is pi times our diameter. So we should be used to this proportion right now, but we said that we're going to compare the arc to the circle. I'm going to abbreviate those there. We're going to compare their angles, and over here we're going to compare their length. All right, so we said we know the central angle of the arc is 70 degrees. All circles have an angle of 360. We're given our arc length is 12 inches. What we're trying to find is the circumference of the circle, which will also be in inches. We know these ratios are equal to one another, and we know we can cross multiply. So when we cross multiply, if I have the same unit on top and bottom, our units actually cancel out, and we could just work with our numbers here. So when we cross multiply, we're going to multiply 360 times 12 and set that equal to the cross product 70 times x. And really, that's 12 inches. We know that when we get our circumference, it will be in inches. All right, so from there, when I complete my cross multiplication, I'm really going to do 360 times 12, and then I know I'll have to divide by 70 to get x by itself. And if you plug that information in your calculator, when you solve for x, you should get 61.714. Remember, we want to round to the third decimal place because, as we stated in class, that's the AP standard, that you bring everything out to 3 decimal places. So that is the circumference of our circle. Now, if I were you, instead of leaving it x equals, I might go back and say that the circumference equals 61.714, so that when I try to find something else, I can keep track of what information I have. And since it's in inches, I'm going to include those units right there. All right, from the circumference, we can easily find the diameter or the radius of a circle. So if I know my circumference, the next easiest thing to find is my diameter. So remember, circumference is pi times diameter. Well, we found our value for circumference already. So I'm going to substitute this, and if it's okay with you, I'm going to leave the units out of the arithmetic, out of the algebraic equation we're going to set up. But we'll know that when we get our diameter that it's also in inches. All right, so our circumference, 61 and 714 thousandths, is equal to pi times diameter. So if you just think about this, if we're just solving a one-step equation here, all I need to do is divide both sides by pi to get the diameter by itself. So circumference divided by pi will give me the diameter. And we could always solve the literal equation first for diameter and then fill in our information. All right, so when I plug that into my calculator, 61.714 divided by pi, I should get 19 and 654 thousandths inches for my diameter. All right, so if I have a diameter, it's really easy to find a radius. In fact, we're just going to do that right here because we know the relationship is that 2 radii equal a diameter. Therefore, half the diameter, or the diameter divided by 2, equals the length of 1 radius. So all we need to do to find the radius is divide this number by 2. When we do that in our calculator, we should get, well, you can do it by hand if you want. You don't have to use a calculator. I would, though, for precision. We should get 9.827. So 9 and 827 thousandths inches for our radius. Okay, once we found our radius, that really unlocks a lot of other things for us about this circle. So if you look at all the work we've done, we can still find the area of the circle and the sector area. So I'm going to move over here on my paper, and let's think about what we would need to know to find the area of the circle. Well, we need to know that area is pi times the radius squared. So if I know my radius is, we said 9.827 inches, all I need to do is square that number and then multiply it by pi. You could really do this in one step. When you square that number, you should get 96.572. And then when you multiply through by pi, and I'm using 3.14, I'm not using the pi button in my calculator, you might get something just a little different when you use the pi button. We should get 303.237. So 303 and 237 thousandths. Now, we've kind of been excluding in our units from the equation, but when we squared our radius, we had our radius measured in inches. When we square that, what do you think happens? Well, when we square inches, we should now have inches squared. So 303.237 inches squared. All right, now that's the area of our circle. So that's the area, and that's for circle B. Let's say, though, that we wanted to find the sector area. Going back to the sector that we started with originally, we looked at its arc. Can we find the area of that sector now? Of course we can. We go back to our proportion again, but this time in our proportion, we're going to compare the sector to the circle. Oops, I started writing the word to there. Sometimes I write what I'm saying. We're going to compare their angles again, but now instead of comparing a length, I want to compare those areas. So the central angle of the sector hasn't changed. In the beginning, at the beginning of this problem, I told you it was 70 degrees. So this is still 70 degrees. Our circle is still 360, and we don't know the sector area, so that's our unknown. We do know the area of the circle is 303.237 inches squared. So if our area of our circle is measured in inches squared, so will be the area of the sector. Again, we're going to just set up our cross products. So I'm going to multiply 70 times 303.237 and set that equal to 360 times x. And again, if you want this to be a calculator-ready equation, and what I mean by that is something that you could just enter into your calculator and hit enter and it'll solve it. We really want to set it up like this. 70 times 303.237 divided by 360. When you plug that into your calculator, you should get the area of the sector. In the area of the sector, the number you should get is 58.963. And keep in mind, we can't neglect our units. That will still be inches squared, since we were comparing area to area in inches squared. So if we kind of take a look at all the work we've done, from just a little bit of information, from just the angle and the arc length, we found out so many other things about the area of our circle and that sector.